All right, so today we're going to talk about translation of functions. So you can see our function up over here. So I want to just make sure that we talk about the end behavior, about what's going on with all of this. So let's go ahead and start first by talking about the degree of this function. The degree of this function, so if I'm looking at this, that first is x, and that outside exponent up here is 1. The next first term is x, and that outside exponent is a 2. And that last term is a 4. And we do have a 1/5 out front. So my degree and my leading coefficient would give me that to be a 1/2 x to the 4th power. And that is again because when I'm multiplying exponents, I do add them. All right, so what does that mean? That tells us that the end behavior of this polynomial is going to be up, do some turns, and up. Now, how many turns? The number of possible turning points, and again, this is the max number of turning points, is always going to be the degree minus 1. So in this case, it's going to be 4 minus 1. So this has a maximum number of turning points, which is 3, which we can see here. The graph is going up, and I have 1, 2, 3 different turning points. Looking at this graph, let's talk about the zeros. The zeros of this function are where it crosses the x-axis, which happen here, here, and here. Now, this graph was originally in factored form, so if I go back up to my original graph, how would I find those zeros by hand? Well, that would be x plus 1 is equal to 0, so x is equal to -1, which is my 0 right there. The next is x minus 2 is equal to 0, and that gives me x is equal to 2, which happens right here. Now do notice with that does not cross the x-axis, it just touches this. I call this a bounce, and that happens, and I kind of like to draw those in boxes to remind myself it does not cross that x-axis. It happens whenever the degree on the outside of the parentheses is even. And then the last one happens at x plus 4 is equal to 0, or at x is equal to -4, which is this 0. So this is all of the different things that I could ask you about how to graph and how to identify things in this graph. But now we're going to change it up a little bit, and I'm going to ask you a little bit more detailed question. I'm going to ask you to graph g of f of x minus 5. All right, now, this requires the knowledge that we had from last unit. What is this doing? This is an inside the function shift. So that means the whole graph is going to shift right 5. What does this look like numerically? What that means is, let's start with f of x. F of x minus 5, right? What that would be my original function, which is 1/5. Everywhere I have x, I write x minus 5. Then it would be plus 1 for the first one. Then it would be x minus 5 minus 2, quantity squared. And then finally, x minus 5 plus 4. And again, all I did from my original piece is wherever I had x, I put in x minus 5. And let me get a bigger view of this graph so you can see what I'm talking about. So wherever I had x in my original function up here, I replaced x with x minus 5. All right, so what does that look like? So g of x is equal to 1/5 times x minus 4 times x minus 7 quantity squared times x minus 1. That gives us new zeros for our new graph at x is equal to 4, x is equal to 7, and x is equal to 1. So let's go ahead and put them up there in the graph. So the new zeros were happening at 1, 4, and 7. And that means that this entire graph shifted here over 1, 2, 3, 4, 5 units, which is exactly what this shift is. So now I can go ahead and copy that. Just be really mindful that, remember, at this last 7, that's a bounce. I'm not going to go across that. So let me go ahead and draw that in. I also want to know where that turn is going to be. So if I come over here and start here, this is going to be over 5 units. So that would be 1, 2, 3, 4, 5. So that's where that turn is going to be. And finish graphing that.